Hello there everyone, and welcome to part 1 of module 12.2, where we're going to give a little bit of introduction to this module and then talk about the Cartesian product. So in the last video we talked about unary operators, and I'm just going to go through this very quickly because if you want to review, of course you can just click back to the last series of videos. But we talked about the select and project operations, which select either a subset of tuples from a relation or project a subset of attributes from a relation. And then we operationalized this relational algebra using our basic select from where block, where we start with the keyword select, followed by a list of attributes, or the asterisk if you just want to project all attributes, the word from, and then the table that we're selecting and projecting attributes and tuples from. And then optionally, this where condition, which is a Boolean expression that is going to be evaluated for each tuple and then return only the tuples for which this condition evaluates to true. We also talked about some basic comparison operators like greater than, less than or equal to, less than or equal to, not equal, which we represent with the less than and the greater than sign together, or equal. We talked about the like operator, which allows us to use wildcards, and we've had several examples of this now in video 4 from module 12.1, as well as some work that we did in the rebroadcast of the Zoom session from March 25th, and we'll have some more examples in the future of using wildcard characters, but go back and check out those videos because this is a really fun and useful thing to be able to do. We also talked about the n operator that compares the value of some attribute against a set of values that we can specify, and in module 12.3 we'll be looking at how we can write nested SQL queries in order to make this n operator a really powerful tool. And then all of these things we can negate by using the not operator. We also talked about null values for attributes and how null is a little bit more difficult to work with, and we can never ask if an attribute is equal to null because null is the absence of any value at all. So we use the is operator when we're dealing with null values. And then finally, we extended our select from where block using these operations like group by, having, and order by. And again, we have other examples of this, but just briefly, I will remind you that group by returns a set of tuples that have a common value for whatever attribute it is we're grouping by. The having operator is very similar to where, but we use this for evaluating the output of our aggregate functions. And then order by just lets us specify some other order to return our tuples in. In this series of videos, we're going to be talking about binary operators. In part 1, this video you're watching right now, we're going to talk about the Cartesian product. In video 2, we'll talk about the equijoin and natural join. And then in part 3, we'll talk about the left, right, and full outer joins. Finally, in video 4, we will talk about our set theory operators of union, intersection, and difference. Now, in some cases, Microsoft Access has slightly different syntax, or some of these operations don't work at all. So whenever you see this symbol here, that means watch out, this doesn't work the same way in Access. And anytime something doesn't work the way you expect it in SQL, or computers in general, Google is your friend. Look at the error messages, Google what the error messages mean, and hopefully that could provide some guidance. Now, one thing you're going to see in many of these examples and in the book as well are aliases for our tables. Now, in one of the previous videos, we talked about using the as operator to create aliases for attributes. And this is particularly useful for our aggregate functions because it allows us to create a nice pretty name for that output, but we can use the as operator to create an alias for any attributes. Now, similarly, we can create aliases for our tables, and we don't have to use the as operator to do that. All we need to do is have a space after the name of the table and then the alias that we want to assign to it. So in this case, we're assigning an alias of C for the course table and an alias of D for the department table. So sometimes we use these aliases just as a form of shorthand to make our SQL easier to write. However, as we will see in an upcoming video, when we're doing queries on recursive relationships where a table is in a relationship with itself, it's actually required that we use these aliases to specify which instance of the table we are interested in. So we'll see an example of that in shortly. So the Cartesian product, as we've talked about before, is all combinations of tuples from the two relations that are participating in this Cartesian product. The relational algebra syntax for this is the name of the first relation and then an x and the name of the second relation. So basically we're multiplying the two relations together. And as we've discussed in previous lectures, the outcome of this Cartesian product is going to have a number of tuples that is equal to the number of tuples in the first relation times the number of tuples in the second relation. And this is the example that we had in the previous lecture, where we have relation C, which are these 12 courses, and relation D, which is these 6 departments. And the Cartesian product of C times D results in 72 tuples, these 12 courses as if they're part of this department, and then again the same 12 courses as if they're the part of the QA/QM department, and then we would have another 12 tuples, that's these 12 courses as if they're part of the economics education department, and so on until we get to 72 pretty useless tuples. And the way we write the SQL code to create the Cartesian product is to say select, and in this case we're just going to say asterisk. We're going to project all attributes from the name of the first relation, in this case C, cross join, and then the name of the other relation, in this case D. And when we execute that, you see we get every possible combination of course with the first department and then the second department, the third department, and this goes on and on for 72 tuples. Now this is one of these things, and you see I have the no access symbol up here because this works a little bit differently in Access. In Access doesn't understand cross join. So if we said select asterisk from C cross join D, and we try to run this, we're going to get an error message. So another way to create the Cartesian product, and the way we would have to create the Cartesian product in Access, is instead of saying cross join, just say select asterisk from C comma D, and now when we run that, we get the Cartesian product, and you see this is 72 tuples just like before. Now we can do the same thing in Oracle. Instead of cross join, we just say C comma D, and when we execute that, we again get the Cartesian product. Now, as we've discussed before, the Cartesian product by itself is not super useful. So I'll show you how we can make this a little bit more useful, is if we say select asterisk from C cross join D. So we can create our Cartesian product and then add our where operator to specify some equality we want to happen. In this case, C.decode equals D.decode. And now when we run this, we get just 11 tuples back, which represents each course and the department that that course is a part of. So that's it for video 1 of module 12.2. In part 2, we're going to be looking at inner joins and natural joins.